Hi, let's talk about how to build an app with GPT. So if you build a classical app, you have the standard building blocks, for example, a database or a web server. Using GPT gives you basically two different new building blocks. And to make sense of it, let's have a quick look at what actually a vector database is and what an embedding space is. So let's say we have different documents and we want to actually make sense of what's inside. For example, you have a text document or a video, and someone is asking questions about the content inside. How can we connect it? So first, what we need to do is we need to convert them into numbers. And we do that by tokenizing it. So this is a text tokenizer. It takes a piece of text and returns a series of numbers. But a tokenizer could also be a video or images, or basically any kind of input. It could be 3D models, it could be video games or songs, or there's basically no limit. What these tokens represent is they chunk up the different parts and give them a number representation. And once we have that, we can convert that into an embedding. Most AI APIs give you some kind of embedding MPI. So we would take the text and then we get back an embedding. And this embedding will be placed inside this embedding space. And one key feature to understand is that similar things, similar content, similar texts would be located in next to each other, where other kind of content they will be more far away. So by doing that, giving new content, we can compare it and then we can pull actually really similar content. And this is an important part. The vector database can be deployed by on your own server. The only thing you need to do in most cases is to call the API to convert the embeddings. In this case, let's say you want to construct a document search. What you would do is you will take your documents and then you will run it through a process and convert them into these embeddings and then store it in your vector database. And once you have that inside your database, you can take any kind of search query and use the database functions to find the closest documents. And these documents can, for example, be feed into a different kind of model. For example, you're asking the model about some kind of reasoning about the documents you have, for example, financial statements. You can do that easily. Another important building block is the prompt engineering. The prompt engineering works surprisingly well. Here on the left, I have the results of this paper called Chain of Thought Prompting. And what they do is basically to show you first that the chain of thought prompting is always better. They have different models, text models, and they run it on different tasks. And the chain of thought prompting is really surprising because we are not using a different model. We're not retraining it. We're not fine tune anything. What we do is we just change the way we give it the prompt. So on the left, we have the standard prompting, question, answer, question. And in this case, the answer is wrong. But what they do is they change the way the question should be answered. So the first pair, the question answer pair, is like an example for the AI. And then you give it your actual question. And then it will respond in the way you gave them an example in the first place. So here what they're doing is they introduce this line, and this line is basically a reflection of the question, like an internal thinking, what we humans also do. When we are thinking, then we might think to ourselves first before we answer to the person. And then the AI model is doing the same thing. And in this time, it has the correct answer. So this paper sparked an explosion of different techniques, which we can all combine and put it in a group of chain of thought. And another example is the a reasoning and acting paper where instead of having like a simple question, what they do is they have different steps, in this case, thinking, acting, and observing. And they do that a few times until they arrive to on a final question. I'm sorry, on a final answer. And let's say we are just stopping here at that point in our application. And what we would do is we would query the AI model basically on every step. And let's say we're on this point currently, and we will give the AI model first the context, so the history of what happened before, and then we will give it a hint on how the next line should look like, in this case, thought 3. We will combine these two texts together and also give them a stop word. You might give them a different stop word. For example, if you want to combine thinking and acting in one spot. But in this case, we are just stopping after the act. So once the AI model wants to produce the act word, it will just stop. And then we can parse the actual thinking and conclude from there, from the business logic, which step to take next. And we will repeat this process until we arrive on the final answer. And the really interesting part is the acting part, because now in blue, you can see here we have search. In the paper, they give them the search action as a way to look up the Wikipedia. But there's no limit in what kind of action you can give them. So you could you could give them a set of actions where the AI is able to choose from. And here it's maybe a bit clearer, where we start with an action, and then we have the thinking, acting, observe loop. And the set of actions could be, for example, going onto internet or using a calculator, querying database. Then you also can decide on the application level when to exit it. And that's it. That's how you can think of the new paradigm in programming and using AI as a tool. And maybe I will come up with more examples, or use different papers as an example on how to do prompt engineering. And if you like this video, please give me a thumb up, and see you next time.